This is section 4.6 on graphing linear inequalities. Alright, so in the previous section, we graphed inequalities of one variable on a number line. So remember, we would draw a number line and then we'd shade, we'd find the endpoint, we'd shade like to the left or to the right of it or whatever. In this section, we're going to combine what we did with the single variable inequalities along with what we did earlier in the course with graphing lines. Remember, with the slope and the intercept. So it's not actually going to be all that bad. Sections 4, 6, and then after this we're going to do 8.8. I know you're probably thinking, why the heck is she jumping to 8.8? You will see. These two go just so great together. They really should be in the same section. Okay, so here's what we're going to do. You know me. I'm going to give you some steps to follow because I like having outlines and stuff here. We're going to use this y equals mx plus b form. Remember, slope, intercept. Here's what we're going to do. We're going to solve for y. Then we're going to graph the line using the slope and the intercept. You might remember this from such hits as chapter 4. If the inequality is an or equal to, we're going to use a solid line. When we graph the line, we're going to use a solid line. If it's a strict inequality, like a greater than or a less than, I'm going to use a dotted line. That's how I'm going to indicate the difference between including the endpoints and not including the endpoints. Okay? Remember, we used a parenthesis and a bracket before. That's not going to work now. So we're going to have to, adapt a little bit. That's where the solid and the dotted line. Third thing, we're going to shade the answer region. If it's greater than or equal to, we're going to shade above. If it's a less than or equal to, we're going to shade below. I realize that steps 2 and 3 sound really complicated because, there's a lot of inequalities happening here. But I think once you see it in action, it's going to make a little bit more sense. This is different than how Hawkes teaches it. Hawkes teaches it a little bit different, and I'll show you that as we go through some examples. But you might want to print out this page of the notes just so you can have these steps in front of you as you go along. All right, let's get to it. So what I did with these is I worked them out, because I go ahead and work them out ahead of time just so these videos aren't as long so that you don't have to see me writing and stuff. Here's the steps that I just outlined for you. 1, 2, 3. And I'm going to explain everything as we go through here. Okay, so let's just treat this as if it were x plus y equals 4. If we were going to graph this, we would get this in y equals mx plus b form. So let's solve this for y. That means I will have to subtract x from both sides. So in doing so, I get y greater than 4 and then the minus x. Now remember, there's no coefficient written, so that means there's a 1 and then there's a minus right here. That means my slope is negative 1 over 1. My y-intercept is 0, 4. So step 2 is to graph this line. So using the slope and the intercept, remember we start at the intercept and then the slope tells us where to go. It tells us to go down 1 and to the right 1. So down 1 to the right 1. There's my next point. Then I'm going to draw a line through it. But what kind of line? Well, because this is a strict inequality, no or equal to, I'm going to use a dotted line. So that's my step 2. So instead of drawing a solid, I'm going to draw a dotted line. Because this has 2 variables to it, the solutions aren't just single numbers. They're points on the xy plane. Okay? So it's going to be some interval of points. Whereas before, we had the number line and we shaded one way or the other, and it was just some interval of numbers. Now it's going to be some interval of points. So which way do we shade? Well, the inequality will whisper sweet nothings into our ear and tell us which way to shade. There's step 3. Because it's a greater than tells us to shade above. The dotted comes from whether or not there's an or equal to or not. Because it's a strict inequality, it's a dotted line. Because it's a greater than, it's a shade above. Now in Hawkes, here's what you're going to have to do in Hawkes. You're going to have to solve it for y, And then you're going to have to, you know, probably put in like the slope, the intercept maybe on some of them. But once you're done with the line, it's going to ask you which region do you want to shade. Now you're not actually going to be able to physically shade it in Hawks. So what Hawks is going to do, it's going to have that line for you after you tell it, you know, where to put the line. And then it's going to say this region up here is A, this region down here is B, meaning above the line is A, below the line is B. Which region is the answer? So because we're shading above, A is the answer. So it's going to have like A, B, and you're just going to have to click on A to tell it which region to shade. A little complicated, but you'll figure it out. All right, so let's look at another one. This one is already solved for y. So it's y less than or equal to negative 2x. Looking at this in mx plus b form, y less than or equal to negative 2x, there was no intercept, so we can just, you know, put a little plus 0 out there. It doesn't change the inequality. That tells me that my y-intercept is 0, 0. My slope is negative 2. There's not a denominator, so we know that that's an understood 1. So we start at 0, 0. From there, the slope tells me to go down 2 and to the right 1. So boop, boop, boop. There's my second point. Now before you go and draw that line, is it solid or dotted? Well, look at the inequality. If the inequality has that solid line, that or equal to, then this line's going to be solid. If it's a strict inequality without the or equal to, then it's going to be a dotted line. So Hawks is going to ask you which one it is, and it really is just, is it an or equal to or not? The direction of the inequality, if it's less than or greater than, that tells you which way to shade. Because it's a less than. How do you know it's less than? Because you know that that kind of looks like an L. So less than means shade below. So it's that. So again, in Hawks, if it has A up here and B down here, you would click on B to shade below. Right? So how does this get weird? Well, we start getting into a little bit more convoluted cases where we have to solve for y, maybe some special cases, things like that. Okay, step 1, let's solve for y. I'm going to subtract the x term from both sides, and then I still have that negative 1 coefficient. I'm going to divide both sides by negative 1. Oh snap, look at that. Remember this, when you divide both sides by a negative, you have to flip the direction of the inequality. Yeah, this stuff's really building on each other, on itself, isn't it? Like this section right here is like some chapter 4, and then you got some chapter 3 in there. It's just like a whole bunch of stuff all thrown in together. It's fantastic. So that gives me this inequality solved for y. All right, now we're ready for slope and intercept. There's my intercept. 5 over 1 is my slope, so I'm going to start down here at 0, negative 4. And then I'm going to go up 5 to the right 1, so right there. Before you go and draw this line, you're going to determine if it's solid or dotted. It is a strict inequality, no or equal to, so it's a dotted line. Now, which way do I shade? It's a greater than. Okay, so there's my step 1, there's my step 2, there's my step 3. It's a greater than, so we're going to shade above the line. So that's it. So this tells you that any point up here, any point up there in that region, if you plug in that point, like just say, I don't know, what's the point up here? There's a point over there. Let's say that's like negative 1, 4. If you put negative 1 in for x and 4 for y, and then do that computation, the answer you get will be less than 4. Now the way Hawks has you do it is where I'm doing step 3 with this shading above or below and solving it for y, Hawks has you pick a test point in each region. So if you look at the instruct area or some practice examples, they're going to ask you to pick a point here, plug in that point for x and y, see if it's a true statement. Pick a point in the other region, plug it in for x and y, see if it's true. So they call them test points. I'm not a big fan of the test point thing. I think that's a little too much work to have to do. I feel like the solving for y business, that if you do that, then that little bit of work sets you up beautifully for everything else, right? Because now you've got slope intercept, you've got an easy graph here, you know, because that's what we're used to. And you've already got it in this form to where, okay, greater than means shade above and less than means shade below. But be careful, don't look at it in this form, because you might be like, oh, well, that was a less than, I got a shade below. No, 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 no. After you solve for y, then you decide which way, the above or below. So I'm not a big fan of the test points, but if that's what you're familiar with, if that's what you see in Hawks and you're like, oh, no, I kind of dig that, that works for me, then do it. I want you to do what works with your brain. All right, next up, we're going to solve for y. So we are going to, there's step one, we're going to put y on the left when we're solving for these inequalities or equations. So I'm going to subtract 4y from both sides, but check out what happens when I do. The y's go away completely. And I get negative 7x is greater than or equal to 28. I divide both sides by negative 7. I have to flip that inequality because I divided by a negative. And I get this. Now here's the weird thing. It says solve for y. There's not a y. Oh, this is one of those special cases back when we were graphing lines. Remember, x equals negative 4 is a vertical line with undefined slope. So we know how to graph it, right? We find negative 4 on the x-axis and we draw a line through it. So negative 4, there's the x-axis, there's the y-axis. How did I know it was a solid line? Because of the or equal to. Now this is what's weird. The less than, we normally would say less than shade below, right? Greater than shade above. But that's with the y's. Because we know that the y-axis, right, up is is greater than and down is less than. For the x's, for this special case, less than means left. And this is just for this one special case. Right, that less than is going to be to the left. Greater than would be to the right. Because think about the x-axis, right? Bigger goes to the right, smaller goes to the left. That's only if you run into this particular special case. All right? So in that special case of the y going away and you just get x, if it's less than or equal to, you shade left. If it's greater than or equal to, you shade right. That's just the special case when the y's go away. All right, so let's do another special case here. Y minus 5 greater than or equal to 0. Let's get that y by itself. So let's add 5 to both sides. I didn't have an x term, so I just put a 0x, just like I did a couple of examples ago when I didn't have an intercept, so I just put plus 0. That means that I've got an intercept of 0, 5 and a slope of 0. Now remember, slopes of 0 means that it's a horizontal line. Remember those y equals lines are horizontal? It's a solid line because it has an or equal to, so there's step 2. And it's a greater than, so we're going to shade above. We don't have to worry about the left or right with y's. It's only with x's that we have to worry about left and right. With y's, it's still above and below. Now, if Hawks asks you to label more than one point, well, you've got this 0, 5. How do I do this slope of 0 over 1? Well, don't go up or down, that's the 0, and go to the right one. So that's how I got those. So all these colors coordinate here. Okay, so if you don't have an x term, that y less than, you're going to shade below, this shade above. That's very similar to what we were just doing with the other ones, okay? It's only the x's that are the special case with the left and right. Okay, so let's do some graphing here. 4x plus 12 is less than or equal to negative 3y plus 12. Let's solve for y, and we need to make sure y is on the left side of this inequality. That's because the way that I'm doing these, the whole above and below business is all dependent on the y being on the left and everything else being on the right here. All right, so let's move this 3y over, and then let's move that 4x over. Okie dokie, I'm going to divide both sides by 3, and I get this inequality. There wasn't a 0 here, so I just added 1 just to show you that the intercept there is going to be 0, 0, and my slope is going to be negative 4/3. So now, graphing this, I'm going to start at 0, 0. I'm going to go down 4 and to the right 3. That will give me my next point. It is a solid line because of the or equal to. And it's a less than, so I'm going to shade below. So this region right here, that is the solution region. That's the solution of all of those points, x comma y, that make the original inequality a true statement. Okay, last one for this section. This one we're going to have to distribute first. So that's why I liked this one, because I thought that the distributing might throw you off a little bit. So we distribute first, get the y by itself by adding 6, and then we have to divide by negative 3. Because this is an inequality, if I divide by a negative, I have to flip the direction of that inequality. So same rules apply as before. So now I've got an intercept at 0, negative 2. I got a slope of 1/3. So come down here, there's 0, negative 2. I'm going to go up 1 and to the right 3. There's my next point. Is this line going to be solid or dotted? Well, it's dotted because it's a strict inequality, no or equal to. It is a greater than, so we're going to shade above. Okay, that does it for section 4.6.